I'm Solveig. I'm with Schnick-Schnack-Systems. We are a German manufacturer for LED lighting systems. Today I'm talking in English because we have some English visitors here, and I assume that everybody is appropriate with English. If you have any questions, you can ask me in German, or for your understanding, later you can contact me. Ich spreche Deutsch, ursprünglich. Our company is based in Cologne, and we are really manufacturing in Cologne. Today the topic is LED color mixing, and especially with a focus on color temperature and light quality, and especially the color rendering index. The topic is very important for me as a woman, for my nails. When I go into the nail polish studio, I want to choose the right color. For you as boys, maybe the Ferrari. So if you go into a store and pick a Ferrari in RAL 3024, you want to be sure that the red is the same in the store like it is on the streets. Therefore, color rendering is so very important. Yeah. We will focus on four topics. One is light quality in general. One is tunable white, with a look on color temperature and the CRI. One is RGB and how colors are mixed with RGB and how to achieve a lighting quality and the CRI that is basically very high. And also the idea of improving the light quality with a system like RGBW, which is kind of connecting two worlds, because then you have a color mixing and content creating or illustrating product at the one side, but you also have a very functional lighting because the light quality is so very high. Everything that I tell today is based on effect lighting. There are several manufacturers, and all of them have different approaches. I know some of them. Usually, lighting manufacturers have patents on their ideas. So I try to mention several of them, but basically I tell you our ideas. It's different approaches, and I do not say it's the best one that we have picked, but at some point you have to make a choice and to make a direction how you achieve the goal that you have set to your company. The question always is like, can you measure light quality? And as light is a very subjective topic, you can answer this with a yes and a no. Some companies have developed a measuring system. It's not only one available, but there are several variations. The most common to us is the CRI, and it's an index that is a quantitative measure to figure out whether a light source is able to emit light that is remitted by the object that is lit. We are comparing these to light sources that we know by nature, and this is the one that is used most of the time. There are other ones that is called, for example, the color quality scale. It's based on a root mean square, so it's a little bit more distortion. The television lighting consistency index, which is based on 24 colors, and the IS fidelity index, which is based on 99 colors. So it's more spread and it's more various, but this one is not really common. And this has a reason, because the lighting industry, when it was changing in the past, the manufacturers of fluorescent lamps wanted to improve their sales. So they compared their lighting and invented something like the the color rendering index to prove that their lamps are very effective and that they are in a very good quality. So they invented something compared to a warm white. First of all, they just choose the upper 8 colors. The color rendering index in total is now based on 14 colors, but the upper ones, these pale and muddy colors, have been the basis to be controlled with sunlight as a basis, and these are exactly the colors that fluorescent lamps are very good at. So they took the measurements exactly to the point where their lamps are good at to make an advertisement how good their lamps are. After a while, people said, well, these colors are maybe nice, but in generally, we are used to see saturated colors like red, yellow, green, blue, and we are also used to see indoors people. So we need a comparison to skin tone and also to plants, like a leaflet green. So these were added. So earlier, the CRI was based on 8 colors, and now it's based on 14 colors. And the most important one that is compared most of the time is the red, because we are the red is the one that is hardly to express by luminaires. It's the wavelength and the remitted colors are very sensitive. So this is the one that is the hardest to achieve. To have a good value in the red area. So the color rendering index is also based, that's very important to know, on 2 very important references for us. As humans, we are used to 2 light sources. One is fire, the other one is the sun. So tungsten is the one that is fire, so we have little emission or little light output at the blue area. We all know candle color, romantic stuff, so that's the tungsten area. So we have a very big portion of red and a very little portion of blue, but the daylight has a very big portion of blue and a very homogeneous spectrum of all of the wavelengths. That's what we are used by the sun. And these 2 are the natural light sources that we know. So everything that we know, we compare to these 2 because we have learned that these 2 are the natural light sources. When it comes to color rendering index, you always have to think of the light source that is the artificial one has to be compared to the same color temperature than the one that is the reference. So you cannot compare a light, for example, a luminaire that has 3000 Kelvin. You cannot compare it to a 6500 Kelvin lamp. So you always have to be sure and make sure that the references are on the same color temperature. So right now we are talking about the color temperature and the CRI in a tunable white system. So first of all, I would like you to know how a phosphor, a white LED, is manufactured. So basically, it's a blue LED. Most of the time, these are indium gallium nitride dyes. So the small little thing in there is called dyes, and it is covered with phosphor. So this phosphor, usually it's called red phosphor, but it emits yellow. I don't understand why they do it like this, but so the phosphor is intrigued by the blue light, so it's forced to fluorescence, to luminescence, and to motivate it to emit yellow light. So as we know from the color spectrum, blue and yellow combined are doing white light. So the sum of the both will be white light. And depending on the thickness and the two wavelengths, or the peaks of the wavelength of these two, so the blue and the phosphor, it will be a warmer white, or it will be a colder white. So when you see what I said right now, when there's a blue LED somewhere here, and on the opposite side there's the yellow from the phosphor, so somewhere in the middle there will be the white, and depending on the assembly of the both together, it will be the white can be shifted. So the idea of tuning the color temperature in one light source is very smart, because you would have to install one lamp only and can achieve many lighting temperatures. For example, in theaters or lobbies of rooms or of buildings, you can have like one installation, and depending on the situation, the circadian daylight, you can adjust the color temperature according to the weather outside, which would look nice, because in the morning when the sun is going up, the white or the walls are looking a little bit warmer and not too blue, so it's not like an opposite, but adjusted to the daylight maybe, or depending on the situation or the necessity of the rooms, the picture that you have seen up here. This one? No. No. This one? So you can see that there's an outside area which is more blue, and the upside or the ceiling is covered with LED tiles, and they wanted to create a cozy room, so they made it more warm white instead of the cool white outside. So that's the idea of tuning the color. And very long time, the manufacturers just had 2 points of tuning the color. So they took a warm white LED, a candle color, like 2000 Kelvin. Some took 1800, so it's a little bit more amberish, and 6500 or 5800, so a very cool, like daylight white. And they just shifted between the two colors. One thing that happens in the gamut is that the straight direction and the tuning in the warm white area until the neutral white will make that the colors shift into a pink area. You don't like this, usually. I like it, but I'm not intended to do lighting designs. So to avoid something like this, that the color, when it should be warm white and shifting across the black body curve to emit a serious and proper white, people have intended or invented different ideas. Ours is to have a second or a third LED installed in the same assembly. Other German companies have done the same at the same time. It's funny that we found out that two of us had the same idea at the same time. So we add a third LED at like 3500, 3200 Kelvin. You can see it over here. That's the assembly. But it makes, or it ends up in a curve that is not really a curve anymore, but it's way closer to the Planck. So the quality of the light, of the white light, is way better because it does not shift so much into the pinkish area. So this is one thing that improves the light quality and the output of the illumination very much because you have a more precise color of the remitting object. It also improves the color temperature, the CRI of the luminaires, because the shift or the addition of the curves would be usually this one and the blue one. I do not know whether you see there's a light yellow one. So this ones would add up to one curve, but instead of just going between these two, you also have a third one that covers up in between. So the wavelengths and the portions of the wavelength that you are emitting to be remitted by the object are way higher. So something like structure, texture, and also the feel of the object is way higher. The University of Darmstadt and Munich have made a study about how people are perceiving the CRI, and I found out usually the manufacturer's declaration is the CRI is above 90 or above 95, and the university just made a study about it. So they checked whether people would love more than 80, more than 90, or more than 95, how we perceive it, because usually if you compare the sun to the sun, it would be a CRI of 100, of course. But luminaires are intending to be as close to the sun or as close to fire as possible, depending on their color temperature. And I found out that people are satisfied with 90. They do not like 95 so very much because they think it's so crisp, and they have the feel, because we know and we have learned that luminaires are not the same like the natural light sources, that we have learned that it is different, and we also have learned that we can deal with it. So the perceiving is that people do not request so much like artificial luminaires with a very high CRI, but more like 90 is fine, and it was published 2 years ago, so it's kind of leading. In our company, we decided to stick with 90 because when the customer don't need it, why should we produce it? We will enter now the area of RGB, color mixing, and also the light quality and the CRI. When an LED is made, or when you use an LED, that's the thing I think everybody of you has seen before, additional color mixing. So you mix 3 colors, and if you combine red and green, it will be yellow. If you combine green and blue, it will be cyan. If you combine red and blue, it will be my favorite color. So this is the one that the LED technology is based on. And as there is form factors of LED, there's something that you have to recognize or that you have to think of when you are using LEDs that are like on panels. Basically, an LED, or call it chip, is manufactured. It has 3 colors in the frames. The upper image, the upper picture, is the old version. You have to think of one thing in that the dark dot at the bottom of the frame is red. So you have 3 colors, red, green, and blue. They are made of different chemicals. These are dyes, and they are put together in one frame and filled up with a silicone. So these red, green, and blue are not in the same spot. This is very important to know, because when you intend to mix light, when these dyes are not in the same position, and you try to mix them, they will have like shades around them, which make different colors. In the middle, it might be the same color, but outside, you will see that it is 3 different colors. There's a color shift because of the position. If you are a moving light manufacturer, for example, they have different ideas of covering it, but they all have to deal with the same issue. These light sources of the different colors are not in the same spot. So some of them, for example, use light pipes, not lightsabers. I always intend to say lightsabers, but it's light pipes. So they mixture the light, and afterwards they use a lens to form the light and to give it a shape. Some of them use lenses that are attached to every single color, and these lenses combine into one. So some of them use mirrors to distract the light. So there's a different idea of every manufacturer. So it's always an approach, and everything has its advantages and disadvantages. When it comes to something like this, like our LED strips or modules that you can see the LEDs themselves, you have to pay attention to 2 things. Always mount them in the in the same direction. That's very important. Imagine the stage would be lit, and you are walking across the stage. There's, at some point, you will have the frame covering one of the colors because of the angle. And if you mix them up, so you have the right at the one side and the right on the other side, the colors that you see will be different. If you always mount them in the same direction, they will always shift the same direction as well. So whenever you might cover the red, then all of them are turning like cyanish, because you will not see this one color. If you mix them up and have them sorted differently, then some LED will be more reddish out of the angle, and some will be more bluish, because the green is in the middle. Do you understand what I mean? This can be avoided with 2 things. First of all, you put a diffuser in front. Diffusers never deal with something like angles. So whenever you put a diffuser in front, the diffuser distorts the light, and you have the sum of what is emitted. Or you use something like this. It is, every single color is in one frame. So when you leave the area of the angle, when you leave the area, all of the colors disappear at the same time. So you do not have a color shift, but they turn off. It's like the security papers on your mobile phones or these security screens. Sometimes monitors have something like, when you move out of your desk too far, then they will be dark. We have tested these. These are quite new. We have tested these, and for example, I found out, of course, because I'm a pink lover, when you are very close to these, you will see 2 spots, and the focus for one color is really hard. This works really great when you are far away, because then you cannot focus then it's one spot at a very distance. If you are close and it's like 2 meters only, you will see that there is 2 colors and they mix up. Of course, your brain is able to adapt this, but your eye focus is 2 spots. For me, my technical department said, yeah, we can use it. And I was like, no, we cannot do a proper pink. So for me, it's not the right solution, but it is there at the moment. And it's an approach of the LED manufacturers to avoid the color shift. So the spectrum of an RGB LED looks like this, because our eye is only able to combine colors. We do not see all colors, but we can see red, green, and blue. So the red, green, and blue LEDs emit light like this. It's most of the time it's a 460 nanometers blue. That's kind of cyanish. These are combined in our mind. Our brain can combine these to all the colors that are in between. So we do not see yellow. We calculate yellow in our heads. And as I said before, this is the visualization of how the 3 colors are doing the mixture of the 3 different colors does not appear at the same spot. So this is a reason why LED panels and backlight systems cannot have lenses on, because if you would put a lens on, well, they could have a lens on, but not in our company, because we are doing quality products. So we would not manufacture something that looks blurry or like color rays on the outside. That's not our intention. In the middle, it would be white, of course, but at the areas around it, it would have these rainbow appearance. When LEDs are manufactured, you cannot really define how they are and what color they have, because it's kind of a natural product. It's a chemical product, of course. I said so before. It's using indium and gallium and a lot of things. But when you manufacture these LEDs, there's a big output. One of the things I would like you to recognize is that the output of LEDs and the sorting is very important. As you can see, there's dollar signs, just to make clear. The production output of one manufacturer, these manufacturers might be Samsung or Nietzsche, Osram, whoever, they are manufacturing, and afterwards they are trying to they are sorting these LEDs, so they are measuring them. There's different ideas of how to measure them. One is for luminosity, so they will be connected, they will be lit up. So they measure the luminosity and put them in one bin. We have the saying binning, lot, or charge for the sorting. Another idea is of sorting them by color. Another idea is sorting them by wavelength. But if you are manufacturing RGB LEDs, for example, you measure 3 colors. So they are sorted in different ways, and they are put in bins. So first, the production output is kind of cheap because it's just the production, and there's a mass of colors and a mass of luminosity. Then they put it in the first sorting, and afterwards they sort these binnings or these bins to more specific one. Our eyes are able to see a difference of 3-step McAdam. That's what our eye is able to see. So depending on the quality of the manufacturer, the binning is more tight. At Schnick-Schnack, we buy the highest binning you can get. We buy with Nietzsche. So our manufacturer is from Japan. It's a high-quality manufacturer, and we have been with them for 18 years now in the RGB sector. In the white sector, Nietzsche has done not so good work in the very past, but the last 10 years they have made a great effort in improving the white LEDs. So 7 years ago we changed to Nietzsche for the white LEDs as well, because they are now serving a quality that we like very much, and also because we can buy a very good binning. You imagine the furniture store from Sweden, and you can buy LED tapes in there as well. They would be the upper part, because they do not care. It's just, it has to be cheap, it has to be many, so they do not pay attention on the sorting. And the sorting is very expensive, so the higher the binning, the more expensive the LED. If you consider an RGB LED, that's the range of our RGB LEDs. Of course, the manufacturers supply different schemes of the LEDs or of the color ranges. So some are more greenish, some are more reddish. And as I said before, here at this point, we are nearly at 460 nanometers. So this is one of the color ranges of our RGB LEDs. And if you combine the three colors like red, green, and blue together, you can see the color range, the white point in the middle. Something that we do in our company is, after we buy the highest binning that you can get, we measure every single LED. So I brought a small case. Feel free after the course to try with it yourself. It's just a small one, and something that we have intended here is we have put the plexi, the acrylic, very close to the LEDs so that you can really see the difference of the LEDs. So I just put something in there that is close to these values, so that we have something like a kind of cold white. This would be, you can see right here that the difference of these LEDs is so very much. It's the highest binning you can buy. So some of them are more greenish, some of them are more reddish. If I put it that way, you can see some of them are more yellowish, and it's the best thing you can get right now in the market. So we do something in our company, and many other manufacturers do the same. They calibrate their LEDs. So they measure every single LED that they have put on a piece, on a lighting module, and they measure it, and they adjust it. So they program for everything data, and they accelerate or store electronic data on the chips to make sure the LED matches the other one. Our approach is to have, like, if you buy 1,000 or 10,000, the complete screen has to be the same color. That's our idea. There's a second approach to that, or a second idea or advantage of it. If you calibrate the data, or if you calibrate the LEDs, you can also age them artificially. Because if you measure them and something breaks, you have measured them before, your customer can send back a piece that is working, like in an architectural installation. And then they can send one piece back that is working, so you can measure it, make a new one, and age it to be in the same installation. So this doesn't work for rental, of course, because in rental things are used differently, so they have all a different time of usage. But right now you can see that calibration makes that the white is more homogeneous and more precise. It does not matter when it is with monochrome like red, green and blue only. You will not see any difference, right? If I put it on uncalibrated, the red, they all look the same. You will not see a difference. It's only happening when it is about mixed colors and pale colors. But then it's important because these colors define or show up the quality of the product. I have another box with me. It's about mixing, because dimming LEDs is also important for how the light is perceived and also how the quality of the luminaires and the lighting is done. So, one of the things that is very important about LEDs to know is usually we dim 8-bit. That has been like the past. So 8-bit means that you have 256 steps. One of them is 0, so you have 255. Furthermore, this means a difference, like every step would be 0.4%. Our eyes are used or able to figure out a lighting luminescence difference of 3%. So, if I switch on my LED independently of the color, just put the channel on step 1 with DMX, then it would be 0.4% on the LED in total. If you put on the next step, like step 2, it would be 0.8%. It would be a double of the one that you have seen before. And your eyes recognize it because it's 100% increase of luminosity. So if you are going to the top, you have 100%, like step 255, it's 100% on. And you take off one step, that's 99.6%. I said the difference we are able to see is 3%, so you will not recognize it at all, because it's only 0.4% of difference. So several manufacturers, for example, also DSRGB or DALI, have invented curves that shift like the steps I have at the top to the bottom to be more soft in the bottom and to be more straight in the top, because you would not even see the difference over there. The first step you could see at the top would be the difference from 100 to 97%. So I could save like 7 steps up there. In between, that was the 8-bit approach or the 8-bit idea. In the meantime, we are dimming 16-bit, so every of these 255 steps is divided again. So it's even more precise and we have more steps to go. I would love to show this to you. In this case, because one thing is fantastic about it to see, we are still with RGB LEDs. So we have 3 colors, and every color has 1 channel. And I do something like a mixture in color. They all get the same data. I have adjusted red to 65%, green to 90%, and blue is like 40%. So because you are right now, and the master is on 100. So right now, depending on the dimming curve that is in the product, you see that there is a lot of color shift or a difference between these strips. The second one is the Dali curve. And the following happens. The Dali curve is the one that is the violet one. So I have green at 90%, red at 60. So with green, I am already somewhere here, so right there. But the other ones, I'm like at 50, so somewhere here, and they are really small. And the other one is even a little bit smaller. So the portion between the three, when you change the master, is completely different than the power linear dimming, just because you are on different ratios with each channel. So one of the advantages of power linear dimming is that the distance, the difference in every step is always the same. So I will not have a color shift in power linear dimming, because every increase I do is always the same relation with the other colors. If I do something like the Dali curve, then the color will shift. It has a reason why the Dali curve was invented. It is an architectural protocol. So it was invented to dim up rooms very smoothly. It is a very slow protocol, so it has nothing to do with DMX or something. It is really slow, but when you enter a room, it does not matter. Today, in the morning, I sat in a plane. I was coming from Dubai, I was trying to get asleep, and all of a sudden, light made bam, in your face. Even though my eyes were closed and I was sleeping, I was like, bam, you're awake now. So something like softness, you would achieve this. This is the idea of Dali. So therefore, it is going slow at the very beginning, and then it's going on, but because you are used to it. So dimming curves that are supplied by manufacturers are always based on different ideas of the approach. So we are used a lot of times in TV studios, so our dimming curves are adjusted to cameras and eyes, so we made a compromise. Ours is not like super perfect, but it's the compromise between eye and camera, because we want to be used in both. sRGB is, for example, the one that you can see in TVs, and it's a standard that is well established, and a lot of manufacturers try to fulfill this standard as well. You can switch our system to sRGB as well. Last topic I would like to go to is RGBW, because it's connecting two worlds. Right now, the RGB lighting modules, they can achieve approximately in CRI about 40. So if you mix the three colors to a 6,500 white and compare it to the sunlight, you will have in CRI of like 40, because the red is really bad, and there's lacking a lot of information in the wavelengths. So RGBW is our approach to increase the light quality of a RGB fixture. There are other manufacturers. You might have heard about RGB Amber and Mint. You have so some manufacturers intend to have RGBW like warm white and cold white. It's always like all of these things work because our eyes are only used to RG and B, and everything that they do is based on the on the color circle. So whenever you have something that is opposite, of course it adapts to white. So in our point, an RGBW module looks like this. So I have the 3 colors of the RGB LED and 1 warm white LED, or other manufacturers, we do in our high power series, we do the same. So we have phosphor LEDs and they are RGB and warm white. So this is like the right one with the dot is the most common. So they are all close to each other, and then they are combined to a light source. They have to be very close. I said so before that also the red, green, and blue are having a color shift because they are not in the same spot. So the same happens with the white LED in here. And now you have something like this. I've shown the color range of our LEDs before. Now we add one thing, and white LED. So we have something that is in there. We tested a lot, as our system is calibrated to emit a very clear 6,500 Kelvin light when we are controlling our system to be at full. So the RGB colors mix up to 6,500. We decided, after long testing, that we will add an LED that is 2,000 Kelvin warm, because we can display already the 6,500. So we added one LED that is very warm white. And it does like this. So I have this 3 colors of red, green, and blue. Red, green, and blue, like this. And I gain some wavelengths or a more homogeneous line of spectrum in adding a white, warm white LED. The control of it works like this. So I do not add the white always. We have invented a system that only has 3 LEDs on. So if I would like to create something that is here, like Zion, I do not add the red LED. I add the white one because it has a much better spectrum. So I have a combination of blue, white, and green. And if I want to do something like amberish, I do have the LEDs on that is green, red, and white. So whenever it is not exactly 2,000 Kelvin white, I only have 3 LEDs on, and one of them is white. So we divided it in triangles to make up the color mixing. So the result of the color is the same, but the quality, because of the spectrum of the other LED, of the white LED, is so much higher, and the wavelength is so much more homogeneous. This increases the CRI to 96 of an RGBW module. And now the following happens. If you would use an RGB module or an RGB luminaire for lighting up a lobby in a hotel to have communication or something, you use an RGB module, it would be very bad in lighting quality, so the CRI would be only 40, and people could feel it. People would not be like happy in that place or feel healthy or wealthy. It would be a place you would like to leave. We know several restaurants that intend us to leave very early. Most of them have golden arches, so we are supposed to buy, eat quickly, and then leave because we do not feel welcome, and the idea is of putting pressure on us. But if you would like to make somebody feel welcome and to feel comfy, you would intend to have a light quality that is above 80. As I said before, the university found out that around 90 we like it the best. So it's adding a white LED. It can be still controlled by video, can be still controlled with single pixel control, can transmit content, but it has a way higher lighting quality, so you can use it as a functional lighting. So it would have more convenience, or more, it would create more comfort with people, so they would use this lighting or this area to feel more happy and more comfy. So the three things I would like to give you as conclusion when you are thinking about using LEDs and having a high light quality, you should pay attention on the sorting. I figure out most of the nearly all of the European manufacturers, they pay attention on sorting, and they will let you know. So whenever you have something to buy or to install, make sure you get the same sorting and you get the same lot or charge. In our company, we track onto the 7th layer of products. So when we assemble our products, we know even a lot of the ICs we have used in your products, and we will store it. And we will pay attention that you always get, or if possible, that you get the same binning again. The European manufacturers pay a lot of attention, but if you, for example, buy at Amazon, like LED tapes, it might be that you buy 20 at a time and you get 6 different binnings. So they do not care at all. So this is one thing you should pay attention to, because you want to have an installation that looks all the same, that has the same appearance. Also pay attention on calibration, because this is something that creates value in your project if it is long-lasting, and also if you intend to use the LED modules more often than once. I know that there is applications where you can use cheap LED ribbon tape whatsoever. I know that these applications are in there, but our attempt or our idea is to create lighting that is good and that can be used several times. So everything that we do is also manufactured to be solid, and many of the manufacturers, especially the moving light manufacturers, do the same, of course, because they want their lamps or their fixtures to be reused and reinstalled. That's the way they make money with it. So pay attention on the calibration, so you can make sure if something is older or much more used than something different, you can get recalibration, for example. And the last thing that you should pay attention to when it comes to colors and the color mixing, pay attention on dimming curves, because they are so different. And it's not like one of them is bad or one of them is worse than the others. It's about the idea, what does your project need? So you have to pick the right one for the installation you are using it in. So if you are manufacturing planes in the future, please pay attention, use the Dali curve. So I will not thrown out of my seat when If you have any questions, I will be happy to welcome you at my booth A53 in the upper level. We also have drinks.